Welcome back to an introduction to basic concepts of maintenance and reliability. In this lecture, we are going to discuss scheduling metrics related to preventive maintenance and predictive maintenance. In an earlier lecture, we discussed schedule compliance, which is a metric that measures overall compliance to the work scheduled. We can get one step further and segregate preventive maintenance and predictive maintenance compliance from remaining work. It is simply the percentage ratio of preventive and predictive maintenance work orders completed within due date to the total number of PM and PdM work orders that were due in a given month or year. So for example, if in a given month a total of 65 PM and PdM work orders were due, however, only 55 of them were completed timely, 5 were completed late, and 5 were still pending as of end of the month, PM and PdM compliance comes out to be 84.6%. An important concept to understand here is when is a PM or PdM work order considered to be timely completed and when is it considered to be completed late. The way you define timely completion matters a lot in this metric. There is no single way set in stone to define timely completion of preventive maintenance and predictive maintenance work orders. Some recommended criterions include to consider a work order to be completed timely very strictly based on the target date. So, if the yearly lubricant change of a gearbox was due by 18th March, it would be considered completed late if it is done on 19th March. Another criteria is to give a single day relaxation according to which 19th March would not be considered late. And finally, a more sophisticated criteria is to allow 20% relaxation in completion date or 28 days, whichever is smaller. In our example, 20% means 73 days. Since we have to consider a smaller of the two numbers, the maximum relaxation we can give in our example is 28 days. It means that oil change would be considered late if not completed by 15th April. If let's say the manufacturer had recommended oil change every 3 months, which is 90 days, then 20% relaxation would have been 18 days. Since it is not larger than 28 days, we would have used an 18 days relaxation. It means we would have considered oil change to be completed timely even if the target date was passed by 18 days. Every maintenance organization should develop criterions best suited to their systems and site conditions before using this metric. Once the criteria for timely completion of preventive and predictive maintenance work is clearly defined, this metric will allow you to track compliance. Another important metric is the overdue work orders of preventive and predictive maintenance. It is simply the total number of work orders of preventive and predictive maintenance that are still overdue, that is, have not been completed despite passing of their target date. So, at the end of every month or in real-time basis, the maintenance department can check how many preventive and predictive maintenance work orders are still pending past their target date. However, the best way to use this metric is to segregate the overdue work orders according to equipment criticality or some other important differentiator. After that, it becomes easy to investigate the most critical overdue work orders and get them completed. However, you don't leave the non-critical ones unnoticed. It is recommended to have a review process in place for all work orders overdue past 30 days or 25% hours if their preventive and predictive maintenance is based on working hours of equipment. The best practice is to ensure that total number of overdue work orders remain less than 5% of total preventive and predictive maintenance work orders. A more sophisticated metric that is based on overdue work orders is the Preventive and Predictive Maintenance Work Order Compliance metric. This is actually not a metric, but a way of presenting another metric called Work Order Overdue Variance. Let's say that the planned frequency for lubricating the bearing of an industrial pump was 30 days. So a work order was created for lubricating the bearing of the pump on the 30th day. However, maintenance team remained busy with other emergency tasks and performed the lubrication on 35th day. It means the actual frequency of preventive maintenance work order was 35 days. The work order variance is calculated as the percentage ratio of actual to planned frequency subtracted from 100%. In our example, it is 16.67%. Now we calculated variance for one preventive maintenance work order. In the same way, you can calculate variance of all preventive and predictive maintenance work orders completed in, say, a given month. Now you can simply create categories of work orders based on their variance. You can further segregate the data based on equipment criticality to get even more meaningful and actionable information. This end result is what constitutes the preventive and predictive maintenance work orders compliance. The best practice is to keep variance less than 10%. That is, all the work orders that are above 10% variance must be looked into for making necessary improvements in the maintenance process for bringing them under 10% variance category. Let us conclude our discussion here so you may absorb what has so far been discussed. See you in the next lecture.